One of the questions I often get asked is, what do you enjoy about your job? And I would have to say it's my research that helps take me around the world to visit different countries and pharmacy schools, which are some of them are shown here. And one of those projects revolve around the mangosteen fruit. You can see that here. Now, if you're not familiar with it, it's because we don't grow it in the United States. It's native to Southeast Asia. Now, if you look at the fruit, there's gonna be an outside purple part, and on the inside is the white portion. That's the edible portion. That's what people typically will eat. And yes, it does taste very good. Good enough to go all the way over to Southeast Asia to try it. Now, if you look at the fruit, you notice that it's very bright. So from my perspective, that's one of the things that I'm interested in. I'm interested in bright colors because they tend to have biological activity. So in our lab, what we will do is we can take different parts of the plant, and we do this with other plants too, and we can pull out some of these chemicals. So what makes the mangosteen unique is that there's xanthones in there, and some of that's shown in the bottom right. So there's actually about 80 to 85 unique compounds in there. So when I look at that, I basically see compounds that could hit different targets. And one of the targets or diseases that I've been interested in is prostate cancer. So the androgen receptor has been a very important target for probably about 70 years. Now, the drug works very well in the clinic to be able to target the androgen receptor, but one of the problems is drug resistance, and it's because of a mutation of ARV7. The thing that we've been able to show with alpha-mangosteen is that it can actually degrade both AR and ARV7. So this is really the first compound that's been shown to be able to do this. The other thing that we've been able to show is a protein-protein interaction where AR and BIP is interacting because of alpha-mangosteen. So we basically decided, why don't we express BIP in our lab, and then we can see if we can find compounds that could bind this. So we basically express the protein BIP, we can put it on a chip and run alpha-mangosteen over it. What we're able to show is that yes, it does indeed bind it. But we wanted to be different than 99.9% of the way that people are doing SPR, or surface plasmon resonance. So we developed a high throughput screening assay. So what we've been able to do is basically screen 1,000 compounds a day and be able to develop a viable high throughput screening assay to look for new compounds or new drugs. And what we're specifically looking at is what we would call BIP-associated androgen receptor degraders. All of this was basically inspired by the mangosteen fruit. So I'm gonna finish with one last question that my daughter usually asks me. She'll say, Baba, do you guys make potions? We make potions. Thank you.